All right. Welcome to our connecting class. Appreciate everybody being here. This is the most number of people as far as percentage-wise of any class that I've had attend. Of course, there's only 4 of you in the class, but I've got 3, so that's not too bad. I want to start out first talking about basic setup. Most of you have been in my classes before, but I want to kind of give you a real quick overview. First, you're pretty much done with Moodle. You've gone into Moodle and you've completed the initial assignment. The only other thing really here is you can get to netacad.com through here or to NetLabs, which is where we're going to do our hands-on labs. But you really don't have to go through these if you don't want. You can bookmark these two and go there. I do ask that about once a week you log into moodle.stanley.edu and just go in the class. That way we're, quote, tracking attendance. Your actual work will be done in the NetAcad class, not in here. So that's why you don't see a whole lot in this. And all you really saw was this first assignment. You probably said, man, this class is going to be so easy because there's nothing to do. Then you hopped over to NetAcad, and inside of NetAcad, the way I work my NetAcad classes is under modules. You will see for every single chapter, listings, oh man, I keep clicking the wrong thing. Listings for packet tracers and also listings for labs. Labs, well, let's start with packet tracers first. Packet tracers obviously are to be completed using our packet tracer program that you can download from inside NetAcad. If you don't have it installed on your machine right now, you can always get it by going to the student resources and then downloading packet tracer. I highly recommend you download the latest version 7.1, uninstall all other versions and install 7, actually uninstall all versions, reboot your machine, then install 7.1 just to make sure you get a full clean install of Packet Tracer 7.1 on your machine. That is what you will use for Packet Tracer assignments inside the course. If you will remember, when you do a Packet Tracer assignment, please complete it and upload your completed PKA and a snapshot showing your score. So for instance, I'm going to open this one and I give you links to all of them. So when you click on it, it takes you directly to where it's at in the chapter and the module. Then you can click and open that particular packet tracer. I'm going to open it up and it takes us a second and it's opening on the other screen. Okay. And so here's the packet tracer for configuring PAP and CHAP authentication. Kind of a funny thing to say PAP authentication when there's no real authentication there, so to speak. No secure authentication. So if I go in here and you notice there's 0 points, but if I go into R1 and I go into the interface S000 NCAP PPP, and you'll notice that I got 6 points. And so I click check results, you will see that on my results, I got 1 item right so far. So I got my encapsulation right. What I ask you to do when you do these packet tracers is complete the packet tracer, save it as your name, and then just leave everything else there. So just for me, I'm just going to put KFC. So I just save this as this and upload the PKA file, and also do a check results, look at your assessment items, grab your snipping tool, and just grab me a quick snip of this and save it as just a JPEG or whatever, PNG, whatever the save is. JPEG's fine. And then upload that with your PKA file. That keeps me from having to open every single packet tracer when I'm grading. All right. Does that make sense, what I'm asking you to do with the packet tracers?
Yeah, that makes sense.
Now, if you have problems, so in other words, you don't get 100 points, what I do then is open up and look at them, and you know, I can basically troubleshoot them there and say, hey, you know, you were having an issue here, we can figure that out. So, all right, is somebody putting something in the chat because I'm not getting. Here's something. Oh, that was Larry coming back in. Okay. So that's how we're going to do the packet tracers and how we're going to upload those. The other items obviously are the actual labs. Some of them, like this first lab, is just researching a topic, so it's just going out and looking at WAN technologies. Others are actually labs inside of the NetLab system. So for instance, this 2327, you can click there and go to that lab and download the document, but you're really going to need to do a scheduled lab inside of your connecting class for the 2327 lab. And you can pick any of the different pods that are available, and you see I have 48 people in my classes right now, so be aware that the pods are going to get used a great deal. Also be aware that if you know you've got time this Saturday at 7 o'clock, notice that you can schedule as far out as you really want. Just please use the pods if you schedule them. If you don't use the pod, or you see you're not going to be able to, you can actually cancel that reservation, and I'll show you how to do that too. So you'll see this lab here. It's actually starting up, but if I had a future lab and it didn't have the inner lab, that maybe it's over the weekend, but I figured I'm actually going to go do something with my wife, I could click and I can cancel the reservation. So please try to use your reservations when you make a reservation. How familiar are each of you with NetLabs? I know, Robert, you're very familiar. Larry, I think you're fairly familiar.
Haven't used it in the past, what, 3 years?
Okay. Remember, when you do a lab reservation, it usually takes about 10 minutes for the equipment to start up. That is because this is real gear, not a simulation. The other thing is, the last 10 minutes of any reservation, you will lose access to the pod because it's going to scrub the pod and clean it. So in other words, it'll be reset to a basic setup so that you don't have to worry about it when you go back in. It'll be set up blank for you to do your lab. So be aware of that. The other item I'll show you here in a minute is about accessing the documents inside of the lab so that you are using the correct documents when you're doing the labs themselves. I do have, Larry, since it's been that long since you've been in a class, I do have uploads for the labs where you'll be able to complete the labs and then upload the documents, and then I can go in and grade those documents. Okay. And that is the same for the packet tracer. You can download, do the packet tracers, save them, and upload them for each one of the packet tracers. All right.
So, Kelly, do you mind if I ask a question real quick?
Go for it.
Do you want us to complete both? And like, let's say we had a PDF document associated with a NetLabs lab. Right. Do you want us to upload that PDF as well as, of course, complete the lab in NetLabs? Yes. Okay.
Yes. It's not enough just to upload the PDF with the completed answers in it. I need to see that you're doing the labs in NetLabs.
Gotcha.
I don't mind if you do some of the labs on your own gear. In fact, I strongly recommend you do that in your classrooms. But I need you to be doing the majority of the labs on my NetLab so I can say, hey, Robert did the labs.
Right.
And be aware, and I hate that I have to even mention this, but be aware that if you just go in and schedule the lab and don't attend it, I know it. If you go into the lab and schedule it and look like you go into it and don't type a single command, I know it. I can see every single thing that you type or don't type. Had an interesting situation where someone just went into the labs and didn't type anything in a class, and I was able to go, guess what? You didn't do anything. First they didn't attend them, then they didn't type anything in them, and I'm like, okay, who are you cheating here?
Yeah.
But be aware of that, that I can see everything. The good news about that too is if you do have an issue, I can go in and look at what you were doing, and many times I can actually pinpoint where the mistake was or what the problem was. Okay.
Gotcha.
So I don't use it just to be mean. I actually do use it for troubleshooting too. All of the tests are on, so you can take the pre-test exam now. And the basic format of the class will be you will read the chapter for the week. You will complete the packet tracers and labs. You notice there's no packet tracer for chapter 1. You will then do the chapter exam at the end, and I usually have the exam after the quiz. The quiz is optional. You don't have to do the quiz, but the chapter exams are not optional. I do have the chapter exams set to let you take them 10 times because I'm using them more as a learning tool instead of a grading tool, really, instead of an assessment tool. So be aware you can take them more than once. I've also done that with other exams like the practice certification exam and the practice exams. Be aware at the very end of this course, you are going to score higher than a 75 on this final exam. You hear me? You're all going to score higher than a 75 on your first attempt, because if you do, you get a voucher that will allow you to take the combined CCNA test at a 60% off discount. So that is something that's available at the end of this course. One thing I learned.
Let's just take it separate. Like we would have to take the composite exam.
Correct. You cannot take it. Unfortunately, they no longer offer the two-part. And I found that out after my summer classes. They had discontinued the giving you a voucher for CCENT and then giving you one for the other. You know, you can always take the second part if you've already got your CCENT, Robert.
Right.
You just won't have a voucher for it.
Gotcha.
So you know, you can pay $150 and do it.
Right.
So, and honestly, if you've already got your CCENT, that's what I would do. I'd just take the second part. I wouldn't do the voucher.
Gotcha.
But the great news is, let's say for some reason you take the second part, don't pass it, you've got this voucher in your back pocket to take the combined at 60. I think it's 68% off. So it ends up being like less than $100.
That's awesome.
Yeah. So it's pretty neat to be able to take it. So, but that's the basic format of the class. Again, read. We'll have weekly meetings, weekly lectures, pretty much. You'll do your labs, you'll do your packet tracers, and then you'll do your chapter exams. Now, you'll notice something. This class only has 8 chapters in it. So it's pretty light on content, to be quite honest with you. When you look, chapter 6 and 7 don't have labs or packet tracers that I've assigned. So this is going to be a pretty quick course to get through. But the beauty of that is it's going to give you time to really concentrate on the big topics like access control lists. These are huge. ACLs are probably one of the most used items in Cisco. They're used for everything. So on most of my classes, I typically say only do 1 or 2 of the packet tracers per chapter. I'm going to be mean to all of you because there are not that many packet tracers in some of the later chapters. So I'm going to ask you to try to do all the packet tracers if you can, and all the labs, all right, for these. If we find out that's too much, I will adjust it, but I really don't think it will be. I think you'll be able to get through these pretty easily once we get going. Okay.
And we'll just do the ones that you got posted up here in the from the module view.
Correct. Correct. If there are if there are other labs or there are other packet tracers that I have not put in here, you do not have to do them for me for this class. Now, you may want to have your students do them in your classes. When you go through here and do this, this is just what I've picked out to do for this first go through. And be aware, this is the first time I've taught the version 6 of Connecting. So we're kind of on, I mean, all this stuff, nothing's new really. For the most part, a little bit of BGPs in here, but we've had that before since CCNP. So there's nothing majorly new that's been added other than some of this PPPoE junk's a little different. But it's going to be our first time through it, so it'll be a good little thing to see it. When are each of you planning on teaching this? Larry and Robert, when are you going to teach it? Chandela?
Next semester.
Okay, so Robert, you're teaching next semester. That's why you had to have it. I think, Larry, you had to have it too, didn't you, for that reason?
It's spring.
Spring, okay, yeah. So that's one of the reasons why I ran a course with 4 people, because I knew y'all had to have it. So, any questions at this point?
What were you talking about earlier? You're going to send out. I was starting to connect, and then I lost connection.
Oh, I was talking about how we do the packet tracers, but also I wanted to talk about when we're in NetLabs and you're doing the lab, you want to show the lab content, and you always want to do the lab from those documents because you see they're updated for NetLabs. And so there may be slight changes between what's actually in, when we look down here at our chapter exam, exactly. So we're looking at the actual chapter lab here. This document in the curriculum, you notice it doesn't say it's been modified for NetLab.
Right.
Whereas the other one does. So we need to make sure that we're using the one that is modified for NetLabs. Okay. Now you will still fill out this document because this is the PDF that's got the form fillable items. So you'll fill out your information and upload this. Okay. But you have to complete the lab using the content that's in here. Okay. It just that way you won't have confusion. It's the same lab for the most part. And in fact, if you don't want to fill out the form fillable PDF, you could just copy these questions, dump them in a Word document, and answer them for me, and I'd be fine with that too. Okay. Just however you want to upload those, whatever's easiest for you. But I do want the questions in the lab answered as you're going through it. They just really help you two ways. They help you, one, learn the material, but number two, you kind of need to know what your students are going to ask you because they're going to say, hey, what does this mean? And you'll be able to answer, oh, okay, yeah, that's that lab that's got that weird answer of blah, blah, blah. So just please do, when you're in the lab, use show lab content and do your lab from that content. All right?
Gotcha.
Let's see, other items. When you got knocked off, Larry, I was discussing how to do the packet tracers. The fact that we're going to have you download the packet tracer, open it, complete it, and then if you can, save me a copy, take a snip of your check results page that shows what you scored and upload that along with your PKA file. Okay. That way I don't have to open every single PKA to grade them. Okay. So again, so you're inside of here, you're doing your lab, you're doing everything, and on the check results page, when you do assessment items, it will show me, you just, when you finish, snip this and upload that as a separate, you know, you'll upload two files, the .pka file with your name on it, and also this file, picture of this. So, and really that's the gist of how the course works. And so it's not that different than you've all had them before, so it's not different where we've been before. May have been a while, Larry, but you've been in them. Yeah. Format hasn't changed much, quite honestly, because it's working. The only thing I do now more is I try to have weekly meetings with you. And I won't be able to, I can't promise I'll have weekly meetings every single week, but I will try my absolute best over the semester. I've traveled way too much this summer, and I'm hoping not to travel that much this fall. So, quick question for you. Did any of you get a chance to read chapter 1? Yes. All right. Robert, did you?
Yeah, I've read through it.
Okay. Well, I want to just kind of go through chapter 1 here. We've got a little bit of time here, but I want to go through it and just talk about anything that is that you have questions about. This entire really section, this entire connecting networks deals with WANs. It deals with wide area networks, and it deals with WAN connectivity, putting networks together. It's always funny when we talk about high-speed internet access or high-speed WANs, because let me ask you, how fast is your internet at home, Larry?
DSL is, I get the highest Windstream would give me. I can't say.
Okay, probably 50 to 75 megabits per second. Robert, what you got?
I got 30 megs.
I got 11 megs. So what's the slowest? Yeah, it finally come up a little bit. Hey, it was 3. Remember when I was teaching at Sunport Mitchell, it was at 3 megs.
Yeah.
I actually got 11. I'm high on the hog now.
Yeah, that's awesome.
But what's the slowest, pretty much slowest NIC you can buy right now? A gigabit NIC. I mean, you try to go buy a fast Ethernet NIC, you can't find one. Mm-hmm. And so a gigabit is the slowest LAN speed that we really have. And we're talking about high-speed internet being 100 megabits per second. What? So, yes, it's high speed, but it's not really that high speed, especially in the United States. Our internet stinks in the U.S.
Hey, you guys, I apologize. I have a gigabit down here in Raleigh, North Carolina.
Oh, just hush. Yeah. I know some of you. Are you one of those Google Fiber people, or are you Fios?
Well, because Google came, I ended up getting AT&T, and then I have a failover of 100 megabits per second for it used to be Time Warner. We got Spectrum down here now too.
Yeah, Spectrum took over everything in our area too. Yeah, it's a crying shame if you live anywhere outside of a big metropolitan area. It's very tough to get decent internet.
Yeah. Which is,
so honestly, if you talk about wanting to improve our economy, give everybody faster internet.
Exactly.
A, we'd buy more stuff, and B, we could do more stuff. So it'd be a whole lot better. But why do we use WANs, wide area networks, which connect across vast distances? It's really just to connect our networks together, to make sure we're able to connect between different LANs. We talk about some different topologies, obviously point-to-point. There's all types of things you can do with point-to-point. Obviously, IP addressing is pretty easy because you only need 2 IP addresses. The other thing about point-to-point is, I haven't seen it used as much, but IP unnumbered, we can actually borrow IP addresses from inside to be used on the outside too. But we don't really see a whole lot of that that I've seen in recent things, because we're going to Ethernet on the outside edges. Here's a hub and spoke. So we got a hub that goes out to spokes, and these could be all sharing one PVC, or they could be different virtual circuits. We'll talk about circuits as we go through the class. Here's a full mesh. I call this somewhat the satanic setup, because everybody's connected to everybody, and you got a little bit of a, usually they do these sites here, and you end up with a little pentagram. And then you got dual homes, which is what we're really, one of the reasons we're even discussing BGP in this course is because of dual home. The idea that you've got an internet connection at your business, you're going to dual home it, you're going to have a connection to 2 different service providers, and when you do that, typically BGP is the best way to ensure routing goes out and, even more importantly, comes back into your network correctly. So we got a little fictitious company here called Span Network that they talk about and how it's growing. It starts out with just a small office who needs internet access using some type of local DSL, cable modem, that type of thing. I think it was Google Fibers now. They quit putting in Google Fiber because they're looking at doing it over wireless, which is it is sad how much faster my cell phone is at my house versus my wired internet connection.
Yeah.
So campus networks, we're looking at, we got a firewall connecting some type of to local internet. It could be a leased line, it could be Metro Ethernet, it could be all types of stuff. Branch networks connecting to internet WAN. Nothing really new here. You can do VPNs between them and the corporate office, so that you don't have to do leased virtual circuits. You can do VPNs, you can do DMVPN, dynamic multi-point VPNs, so you can do all types of hub and spoke type stuff. You have VPNs come up automatically, depending on how you've got your network set up. And so we got distributed networks. Span networks is going to go from one site to multiple branch and regional offices. And how are they going to do that? Well, they're going to do it with a VPN setup. Now, it can be a site-to-site VPN, which would be a branch office, which has its own static IP address going across, or like again, we can do DMVPN, going across to the central office. The telecommuter can do a remote access VPN. And these also can be VPNs that are client or clientless, so they can be SSL VPNs, just depending on how they are designed and implemented. It's much cheaper to do this now because you don't have to maintain banks of dial-in modems. That was a way to do it in the past, but obviously we're away from that now as we've got a little bit faster internet. So now this is very interesting and something I don't think many of us have thought about very much. WAN technologies all operate at layers 1 and 2. Think about it. HDLC, layer 2 protocol. PPP, layer 2. Frame relay, layer 2. MPLS, layer 2. Below that are all the electrical, mechanical, and operational connections. So when you think about WAN services, most of them are layer 1 and layer 2 services, if they're just WAN services. You can't say that IP is a WAN service because we run that internally on our LANs too. So the first couple times I went through this course over the years, it always interested me to think about how WANs and their protocols are basically layer 1, layer 2 portions, or layer 1, layer 2 components. Oh, here's something very good too. Think about a point-to-point link. You don't have to worry about layer 2 address fields. Why? If it goes out one side, it's got to go to the other side if it's point-to-point.
Yeah.
So I don't really have to worry about the other side's, layer 2 address. I don't have to worry about a MAC address. Now, as we get to Metro Ethernet and doing some other things get a little bit different. But in a true point-to-point setup, if it goes out one side, it's going to go to the other side unless something majorly messed up. Here's some terms we need to kind of know from just to be able to talk to our telecom. Customer premise equipment, that's equipment that is owned by the customer. It used to be the CPE equipment did not have the DCE component to it. The DCE would have been owned by the service provider. And remember, DCE or data communications or data circuit terminating equipment, depending on how you read it, is usually what provides for clocking on that particular interface. Now, since we've kind of moved these DCEs into WIC cards versus being an external ADTRAN box or something of that nature, or as this becomes Ethernet out here, we really have the DCE, DTE equipment being owned by the service provider. Okay. I'll get it tomorrow. I'll look tomorrow. Sorry, too busy today. And then the DTE equipment is a data terminal equipment, and that's usually a local router. And then we've got our demarcation point, and this is where the customer equipment ends and the service provider equipment begins. It's so funny, I've had some trouble with my Windstream internet, and I always have to tell them, look, I can get to my local router, I can ping, I can get in this router, and I can see, guess what? Your DSL loops are not training. I cannot get it, it shows it. It's flapping, it won't train, it will never. And I basically have to talk to them and say, you need to go look at your switch, and then sure enough, something's wrong with the switch, and they go fix it. Central office, that's where the switches are at. Sometimes those switches are located out in the environment, kind of like that. And we're talking about this long haul network, which is a toll network of big service providers. Anybody read about the new cable? I think it was Facebook and Microsoft just put across the Atlantic. It's a fiber optic cable that will go. It's going from Virginia Beach, Virginia, to a place in Spain. And the reason they put it there is because Microsoft and Facebook both have a large number of data centers in the Virginia area, which I thought was pretty interesting. They worked together to put this 4,000-mile cable across the Atlantic.
That's amazing.
Yeah. If you've ever looked at those, there's a couple diagrams. You can actually see what the cables are throughout the U.S. and throughout the world. One of the big issues with 9/11 was that many of those cables went right into Manhattan. And so as soon as 9/11, kind of settled down, they started laying cables from Jacksonville, from up north in northern part of New York, to get across to make sure there wasn't a single point of failure for those cables.
Wow. So
some common WAN devices, a dial-up modem. I will not say that's very common anymore. In fact, can anybody tell me the last time they saw a dial-up modem?
1995.
Yeah, I'd say it's in the 90s.
Get off the phone.
Yeah, exactly. I need to get on the internet, get off the phone. And that crazy sound they used to make. You used to make that sound now, and kids just look at you like, what is that?
Yep.
That's the way we got on the internet, folks. Access servers, again, those are normally used to connect to dial-up banks. We use an access server on NetLabs, but we use it to do reverse telnet. That's the only thing it's used for. So broadband modems, that's DSL or cable modem. CSU, DSUs, again, since we're going so much to Metro Ethernet now, we don't even see as many CSU, DSUs out there because we don't have leased lines per se. The WAN switches, those are specialized switches. The frame relay, ATM, Ethernet now, MPLS, routers obviously are WAN devices, and then you have core multi-switch layers. And this is not exhaustive. There are other technologies out there. This is just the ones they kind of mentioned for you. Now, what is circuit switching versus packet switching? This is old school right here. If you've ever watched the real old TV shows when they pick the phone up and say, operator, I'd like to talk to so-and-so, and the operator literally takes and connects one cable to a port and another cable to a port. In some ways, that's how circuit switch works. You dial, and when you dial, it sets up a link that is used for that conversation and maintained for that conversation. And then once that conversation or data exchange is completed, that particular circuit would be broke down. Many times they are actual virtual circuits, but they're permanent virtual circuits. So anytime you're going from A to B, it would go the exact same way. Sometimes it's switched virtual circuits where it would go A to B and it would find a different path depending on what's going on in the cloud at that time. But the key here is with circuit switch, it actually has to have a call creation method. It has to have a call establishment method and a call termination method. Then all the information goes across that circuit switch. ISDN is an example of circuit switch technology. Frame relay and almost all of our newer technologies are packet switched, which means we take all the information, we turn it into data packets, break it up, segment it, throw it out in this packet switch network, and then let this connectionless system figure out the best path across, okay, and let it go, okay. Now, it can be connectionless or connection-oriented. Again, that goes down to switch virtual circuits versus permanent virtual circuits. So the beauty of packet switch is if congestion exists on the path it should be using, then it can go to a different path. It also is very nice because you don't have to, you can break things into smaller segments. And if you have to resend anything, you don't have to resend huge amounts of data. You can resend smaller pieces as you put them back together with your TCP segment identifiers. Any questions?
Yeah, I got a quick question.
Shoot, go ahead.
In terms of voice over IP, technically, is everything VoIP now? Is everything going to a digital format with voice, even at our house?
Yep, my understanding is once everything it's analog to the switch, and then everything becomes digital.
Okay.
Yep. Now I can't promise you that because I don't work for the phone company.
Right.
But that's what the guys that I know that work for the local phone company have told me is it's the only thing that's really analog now at this point is out to your house. And even some of that's digital because you've got digital signals running across it.
Right, and it makes sense because like the only thing connecting you to your ISP is that coaxial.
Right.
Like for if you have a cable provider.
And actually, if you're doing cable telephone, it may be it's all digital.
Right.
I don't think any of that's analog, but I can't promise you that because I honestly don't know. If anybody else knows, please chime in because.
Yeah, that's correct. At least that's my experience when I had Time Warner for my telephone provider. And then on the fiber side of it, come in, you have a smart jack, and then it runs, runs to the modem, and even from the phone there, it's really voice.
Exactly. Yep. All right.
Well.
Yeah, especially when you have gigabit internet, right?
Yeah, I wasn't gonna bring that back up.
Yeah, that's okay. I'll bring it up for you. I'll rub it in for you. How's that? All right. So when we look at our WAN options, we've got public and private. Obviously, public, you've got the internet using broadband, VPNs with anything from DSL, cable, wireless. On the private side, you've got switched, and honestly, packet circuit switch with PST in packet plain old telephone system or public switch telephone network. It's not that big a deal anymore. ISDN, obviously, in the United States is definitely not a big deal, and really not many places in the world is still a big deal. But I would say Metro Ethernet, MPLS, those are the big things kind of taking over in the packet switch world. And they pretty much replaced leased lines just because of the ease of implementation and the cost. They're so much easier to maintain, so much easier to, if you need more bandwidth, you can stick a faster switch on each side and pay a little more money, and you can get a faster Metro Ethernet connection.
Kelly, I wanted to chime in here too because
sure, go ahead.
With CenturyLink as a service provider,
yeah,
they still are surprising a lot of customers that are using T1s, and they'll bundle those T1s up and everything to try to bring their speed up. I was surprised to really see that, but these are some more remote customers and things
Right.
like that.
Well, and I'm sure you've got a lot of manufacturing companies that still do that just because it works for them, and they're scared to death to switch. Maybe their speeds are, a couple T1s is enough to give them what they need.
If not, though, to be honest with you, a lot of times if they perform a backup, then we'll get some alerts on the monitoring system. They say they had like 90% utilization and things like that.
Right.
The circuits go down a lot. So it's kind of create that business model that we've been doing because of people not really wanting to upgrade and everything.
Right.
And also I see some the multi-link frame relay as well.
Oh wow, really? I tell you, the interesting thing is we had a fractional T1 at my wife's business for a good while, years and years ago, and this is a long time ago. But we decided to switch out to a business DSL connection. Well, we got 5 times the speed, and it was 1/4 the price. And now the negative there is, and this is probably why a lot of the people are staying with the T1 links, is your service level agreement. If I'm getting a T1 from you and my T1 goes down or multi T1s go down, I'm on the phone screaming and you're going to get it fixed. If my business DSL is down, their service level agreements are much lower. So I do understand in some ways keeping those lease lines for that factor.
That's one of those services where you're like, oh, we'll be out in a couple of days.
Yeah, meet me between 9 and 12. Yeah.
Okay.
Here's some things on SONET and dense wave division multiplexing. This is basically looking at long haul fiber communication. So with DWDM, you can do 80 different channels on a single fiber. Each channel can do 10 gigs. So you're looking at 80 gigs of data on a single piece of fiber. Really, we don't even know the true data carrying capability of fiber. It's just basically whatever we can stick on it. So we're limited by the devices on each end. That DWDM is what's used on the submarine cables. So the long haul circuits that are out there are what's going across the world.
Hey, Kelly, one last interruption.
Shoot, go ahead, please. Anything.
Just some inside knowledge is that they are testing up to 200 and 400 gigabits per second right now.
Isn't that amazing? Think about that, 200 gigabits per second on a single fiber.
That's insane.
Yeah, it's going to be awesome. I'll die long before it gets to my house, but.
Yeah.
So again, lease lines, this is where you go in and you do have a CSU DSU. You go in and get a standard. Now they say the standard in the U.S. is a T3. I would say T1 more than T3, which is a 1.544 megabit per second link. It's a T1. The E1 is 2.048 megabits per second because the Europeans just have to be better than us. It actually has to do with their B channels, the way they use the B channels on a link. They have more B channels on it. T3 supports 43.7, E3 is 34, so our T3 is better, but their E3 is a little slower. But the advantages are simplicity, quality, again, point to point. You're not sharing that with anybody, it's yours. Quote, you're not sharing it with anybody because once it gets on the service provider network, they may be doing some weird things with it. And then availability, and that's really, to me, the biggest thing there is availability of that service level agreement of saying, hey, what just happened on my monitor? Somebody just, hold on a second. What in the world? Okay, sorry y'all. Daneware monitor thing just popped up. Okay. But the availability in that service level agreement, you can really drive it to somebody and you got a lease line, they're going to get out and get it fixed. The negatives cost, it is more expensive than some of the other models, and it is less flexible. because you're not able to build out, you know, those virtual circuits as easily. If you're doing a lease line, you do normally have HPLC or PPP, depending on how you're doing it, or frame relay, just depending on how it's put out there and what you're doing. Dial-up, I don't know why they put it in here. If you got to use dial-up, life's terrible. All right. ISDN, I haven't seen ISDN in the U.S. in a very, very long time. We used to teach it and even teach you how to configure it in the Cisco CCNA curriculum, even though it really wasn't in the U.S. at the time still. But I did have a student take a job and ended up having to help his company configure ISDN at Mexican plants. And he said, you wouldn't believe how hard it is to do ISDN in Mexico. But ISDN has two rates, basic rate, which is two 64K channels and one bearer channels, B channels, and one 16K D channel. And then in the US, you got PRI, which is 23 Bs and 1 D. And there's some overhead in there too that really makes it a little more than that. This is ISDN BRI, 144 kilobits. And then ISDN PRI, 23 B channels, and then 1 D channel. And there's a little bit of overhead here. It's actually a little more than 1.544, but they always call it 1.544. Frame relay, we'll talk a little bit, we'll talk about this, but we won't actually teach how to configure it anymore. It's been taken out of the curriculum. But you basically just do encapsulation frame relay, set up your local DELC, and then use PVCs that go across a frame relay cloud. So you're connected to a frame relay switch, which could be a router or just an FR switch, which is a router also. And then it goes across to through this frame relay cloud to the opposite end. I'm not going to spend a lot of time on that because it's just not that prevalent, and it's not on CCNA, but I will say, like Sandella said, there are some places that are still using it, so it doesn't hurt to go over it a little bit with your students. ATM, just remember it's 53 byte cells, 5 bytes overhead, 48 byte payload. That's pretty much all you need. It went away really quickly when we started getting gigabit Ethernet. And then we got, this is the big one here, and this is Metro Ethernet. So we've got a service provider, Metro Ethernet, running MPLS or running whatever flavor they've got in their service provider network, and you just connect an Ethernet connection, and they give you a connection between your different branch offices and different offices within that particular region. Very nice because you can get fast connections. Very nice also because you can do, you can pretty much easily upgrade if you need to a faster speed. And in MPLS, again, we don't spend much time on that here, but you have a cloud where you connect, and most time you can connect by just about any type of connection topology or connection type to the customer equipment, and then that connects into the MPLS cloud. And the best way to think about MPLS is think of it as VLANing or tagging WAN traffic at the cloud level, at the service provider level. So you basically are dropping in an MPLS tag or a label, so it's a label, and then those labels are used to move information through the MPLS cloud. It's technically supposed to provide security because traffic with two different labels on it are not supposed to be able to be seen or be intercepted by one another. So it's a lease line connection to an MPLS cloud. We don't spend a lot of time on that here. That is something that's on the CCNP a little bit. Satellites, again, it's a WAN service, but you know, unless you're military, very few people use VSAT technology to actually move information between sites. All right, I'm going to spend a lot of time on DSL because I think most of us are fairly familiar with it. One of the things I will talk about a little bit is this DSLAM, which is at the point of presence. This is what's at the switch for the for your DSL providers like Windstream and others. There is a distance limitation between the DSLAM and the DSL modem. I think it used to be 15,000 feet to 1.5K was the distance. Now it's a little bit further. They can actually push it out a little bit further, and you can get further and have less signal strength, They have ways to boost the signal strength now, but that is one of the negatives of DSL is if you're not close to the DSLAM, you're not going to get fast speeds. Cable has the same type of thing with this cable modem termination system going out. It does have the ability to go a little further, and well, a lot further. And part of that is it's not going in on, you know, RJ45 cables. It's coming on RG6, which is a bigger cable that can carry a little more robust signal. But again, there's still limits to where it can go and how far you can be from the termination point to your cable modem. Wireless has really come in. I mean, like I said, it's sad that my 4G connection is faster in my house than my internet speeds. The other day, I was actually testing internet speeds, and I didn't realize I'd turned off my Wi-Fi and only had on my 4G. I was like, man, I'm getting 20 megabits per second. Then I realized, oh, okay, I'm going across the 4G. And I turn on the Wi-Fi, and next thing you know, I'm back at 11. So this is, I won't say it's not just probably the wave of the future, it is the wave of the future as we continue to be able to push those speeds even faster. The only negative there is there's bandwidth caps, and those bandwidth caps, there's got to be some information brought about or some things changed about that. So LTE, 4G, VPNs, we'll talk a lot about those. We have an entire chapter on doing a GRE, but doing VPNs where they can, this is a site-to-site VPN, and that is from a piece of networking equipment to another piece of networking equipment. You control both ends, so you know what IP address is on each side, and you can do a site-to-site. And there's remote access VPN, where this is your teleworker who's traveling all across the country to different hotels. And so you'll notice the difference between a site-to-site and a remote access is the termination point, and the fact that in a site-to-site you have no software to be loaded on the actual PCs in the LAN. The tunnel is between the two networking devices. Whereas on a remote access VPN, because you don't control the actual router you're going through, the tunnel has to endpoint at the teleworker. So it has to actually endpoint on the computer. So you have to load software or use SSL to make an SSL VPN. The beauty is it's really secure. It's very scalable. It makes remote access much cheaper. What's horrible is it means we can work 24 hours a day, 7 days a week.
Tell me about it.
Yeah. They'll be like, oh, you can jump on a network and do this. And okay. So I'm going to let you read through this section on just choosing your WAN, and then that is it for Chapter 1, folks. Our next chapter will be Chapter 2. Are there any questions?
Yeah, Kelly.
Yes, sir.
Should we be also reading from scaling networks?
If you're in both classes, yes.
Okay.
But if not, then you just do this one. You do this one. I know some of you are actually taking both classes, scaling and connecting at the same time. If you are, you've got to be reading both and really trying to attend both if you can. If not, at least reviewing the other class meeting.
Okay.
All right. I'm going to stop the recording real quick.